All right, so I wanted to make a quick video, well, pseudo quick video, to go a little bit more in depth into state machines. For those of you that were unable or not in class, didn't stay, or just want to have a rehash, I'm going to start back where I started in class this last week. And that's mapping out what our state machine is going to look like. So you can use just a piece of paper to do this. You can use what I'm going to use here, which is Miro, which allows me to do it on the computer. Whatever it is, you can just write it out. But something that kind of gives you that idea and plan for what exactly your system's going to be like. So I'm going to use Miro, Miro.com. And I'm just going to do it through a bunch of sticky notes, but then I can draw lines and make some notes on it. So we're going to once again have our robot be our AI. So we'll call robot AI. Why not? All right. And so from this, we're going to have, for this one, we're going to have three different states. I want the robot AI to patrol. So I want it to be walking around our area, exploring, making sure that nothing is out of place. We're going to have I'm going to do this in a different color. Actually, we'll make this one. I'll write these first and we'll get different colors. Well, patrol state, we'll have an idle state. And then we're going to have a healing state. One more. Or we'll call it recharge. Well, yeah, we'll just go with that. So we'll have patrol, we'll make it active in orange, idle, blue, recharging, green. Right, so when zoom in a little bit, make it a little easier to see. When it's patrolling, it's going to be doing one thing. At a certain point, it will switch to an idle, but we're also going to have a recharge. And so we're going to start our AI in the patrolling. Right, that's just going to be what our starting motion or starting state is going to be. The AI is going to be going out on patrol for whatever that reason is. And so, actually, let me move this here. And then, when it's been on patrol for a certain amount of time, it's going to go to an idle state. So we're going to attach that coming here, let's say after 10 seconds. So now we have, after 10 seconds, we're coming to idle. And then from idle, we're going to idle for roughly, we're just going to idle for 10 seconds as well. And we'll do it after 5 seconds. So after 5 seconds, idle is going to switch back to patrol. That's going to continue to patrol. And then another 10 seconds, it's going to go back to idle. The other thing that we're going to do, though, is we're going to say that when it's patrolling, it's losing a certain amount of energy. So we're going to add a variable to our robot AI in that main controller, which we'll get to when we get back to the code. We're going to add energy. We'll just call it a variable. It's going to be of the type integer, so it's going to go whole numbers, and we're just going to call it energy. Robot energy, why not? And let's call it, let's just say it's 100, right? So full battery, it's got 100 energy. So patrol, because that takes a lot of energy, minus 5 energy per second. So when when the robot's patrolling, it's going to lose 5 energy per second. And then when it's idling, it's going to lose 1 energy. Should actually make this correct. Robot energy. You can write it in code. Robot energy minus equals 1. And then we can do, just update this one. Robot energy minus equals 5. All right, so with that, we know that every second in patrol, it's going to lose 5 energy. And idle, it's going to lose 1. So at some point, there's a chance that idle and patrol are going to lead to a potential need to recharge. We'll just pop that one up top. And it's going to be the same thing. So when robot energy is less than or equal to, let's call it 25. And we can, since we're just making these as notes, we can duplicate that and we're going to drag it down here. So it doesn't matter whether it's in the patrol state or the idle state. When the robot energy is less than 25, less than or equal to 25, we're going to go ahead and move to the recharge state. And then recharge will always go, we're going to have recharge always go back to patrol, but we're not going to do that until robot, should actually get my fingers on the right keys, robot energy is greater than or equal to, let's say, 85. Right? So we've got now what our robot's going to be doing. It's going to be patrolling, idling, and recharging. Every time it's on patrol, it's losing 5 energy per second. When it's idling, it's losing 1 energy per second. On patrol, after 10 seconds of patrolling, we're going to move to idle. After idling for 5 seconds, we're going to go back to patrol. And that's going to keep going in a loop until either on patrol or in idling, the robot energy dips below 25 or below. And then that's going to automatically have it go to, doesn't matter which state it's in, it's going to go to the recharge state. The recharge state's going to stay in that state until it's 85. So we can actually say that over here, robot energy plus equals 2. So we'll add 2 energy per second. It's just what it is. It's fine. Per second. All right. So from this, like we talked about, we're going to be able to translate this directly into what we're doing. And so what we're going to also do on this, just to make it really easy and obvious that our states are changing, we're going to change the robot's color to these different colors when we enter these states, just to make it super clear what we're going through. So, okay, I'm going to pull this off to the side. We have over here this is a version of our system that we've been using. This is the data scene. We're going to go to the scenes. I'm going to duplicate the sample scene again, and we're going to call this new state machine AI scene. Why not? And then, so like usual, we're going to double click to go into it. We lost our wall controls. That's perfectly fine. We don't need it for this. We're going to... we can go ahead and... I think with this, we're going to actually... can leave these. That's fine. We're going to end up actually, instead of the robot that we currently have, because we don't need all the advanced stuff that we had before, we're going to go ahead and just turn this robot off. Actually, I'm going to leave them on. What errors do we get? Let's just see if there's anything that's too much to deal with. It looks like it's okay. So we're just going to leave him, actually. So we're going to have two AIs running around the scene doing different stuff, which is great. So what we're going to do for this new robot, we're just going to do a 3D, we'll just do a cube like we've done before. We're just going to call it Robot 2, so I'm going to change the name to. And then, let's see, where do we want to go from here? We're going to... let's just go ahead and into our scripts, create a new folder, and we're going to call it New State Machine, just so we have them separate. And then, okay, I think what we'll do, we're just going to start with making the scripts that we need, right? So we know, we'll just go in here to our new state machine. And we're going to create a script. And if you remember right, we're going to have a new robot state. That's going to be what's going to be used to format all the rest of the scripts that we're going to use. So we'll have that one. We need to have our controller. So we'll call it new robot state controller. This is where all the pieces that we need to keep in mind when we're doing the state machine, all the variables, all the controls are going to go through there. And then we'll have, so we can think of those two scripts as our robot AI. So in the state controllers, we're going to have our variable for the energy. So then let's create the patrol, idle, and recharge scripts. So we're going to have create C# script, new robot patrol. We can just call it new robot state patrol. We want to make it 100% clear. And then we can have new robot state idle, and one more unforgettable script, new robot state recharge. Okay. So we're going to, I'm going to open these up and I'll drag them on to the screen in just a second because they're off at the moment. All right. Then okay. So let's bring these over. So, while we have, once again, what we're shooting for, right? We're going to create this state machine where this is the robot AI, and it's going to go through these three states. The three states are three different activities, basically, that's going to be going through. Once again, one's going to be patrolling, one's going to be idling, one is going to be recharging. So those are the only three states that our robot can have at this point in time. So what we're going to do is, but we have to set up the robot itself first to work with the different states that we want to have. So that's what we're going to be setting up first. And to start with, we're going to need to set up our new robot state. This is what's going to be the class on which everything else is based on, if that makes sense. And so what we're doing with this, we're changing it from mono behavior, which is basically just a script that it's going to run some code, potentially connect to some other things. That's not what we specifically want. We want this to actually be a abstract class of the type new, that's called new robot state. And so I would love to give you full details onto how and what everything means here. I haven't actually researched it all. I was just taught this when I was a GIMM student, and this is the way that I've always known to do it. And other things that I've seen do it the exact same way. So this is where, and I have still had comments about like, oh, am I using my own code? If I'm using something for class, or if it's something I found on the internet. You are, as long as what you're doing is you're typing it yourself. You're not just copying the script over, Control A, Control C, Control V, or literally just adding a script that you've done nothing to your code. So this fits perfectly into, quote, code you've done, because we've been learning it. So in this, what we're going to do is we're going to start by telling it what the robot state controller is. What is the piece that is controlling the robot specifically? And this is really just going to set up the new robot state is just setting up for the other states. And everything is going to then connect back to the robot state controller, or in this case, the new robot state controller. So we're just going to start with a protected and calling out to the new robot state controller. And we're going to call that the NRSC, the new robot state controller. This could be called anything. This is just the variable name. I usually do this just so I keep a memory of which direction I'm going to. And so then for that, what we want to do is set up the different functions that are going to run in each state. So we're going to create the first one, and all these have to be public from this point on, because we're going to be accessing them outside. So public, this is going to also be an abstract void check transitions. Nope, that's not how you spell transitions. Transitions. Oh, and it's a function, so we need to make sure we have double parentheses, right? So we're going to check and see at the very start, does this need to transition? Is there some reason, has it hit, like, bring this back over, right? So while it's on patrol, has its energy dropped to less than 25? All right, now we need to transition. Or has it gone for more than 10 seconds? Okay, we need to transition. So we're going to have that as part of that. Then we're going to add in another, I believe, public abstract void. This is not going to be the update, even though it wants it to call it that. We're going to call it the act. So this is the actions, right? What, if it's not transitioning, what action is it performing? Is it patrolling? Is it healing? Is it just sitting there? What is it doing when it's in that state? And then what we want for ours, we're going to have two public virtual voids. and they're going to be our on state enter. And we're going to have one more on state exit. And these names are not specifically the way they have to be. We could change these. It could be public abstract void action, public abstract void do this while in this state, whatever it needs to be, right? We just have to make sure that in our actual states, this is the format we're picking all the way through. So we don't get to add new stuff into our states unless we add something here. And if we add something here, it has to then be added to every one of the states. So that's the important thing with this. So if you wanted to have something else that fell in there, something, not really sure what you would put, but you could add something that's visual effects, or something that specifically checks something else in the environment or something like that. I haven't found a need to add any other one. I'm sure there is some situation where it's been, but that has not been the case. And so then what we're just doing to end this out, we're doing a public, and we're calling back to our new robot state, and we're going to attach that to our new robot state controller, just like we had done before, connecting it through this way. And we're going to say this, which is related to the code, new robot state controller is equal to the robot state controller that we have in here. So this, once again, this just lives like this. It doesn't actually get attached to anything. It's really just setting up how everything is going to be formatted. And so you can consistently just use this with all your state machine AIs. And that's just the way it is. All right. So what we want to do from here is go into our robot state controller. So we'll come over to our new robot state controller. We want to make sure we're adding to this, though, that we're using the Unity engine .ai. Right, this is going to have a lot of AI calls to it. We're going to connect to a lot of things. Here, we're going to set up a lot. Every variable that's connected to the robot has to be on the state, the new robot state controller. Whatever the controller is that's controlling your state machine, this is where all the main variables are going to be stored. Anything that needs to call out to the rest of the environment, to the rest of the program, all need to be done through here. This is kind of the connection point between the state machine and the rest of the program, and how the state machine itself is going to work with itself. So what we want to do with this is we want to go ahead, and because we're going to keep the start, and we're actually going to keep the update because some things are going to happen in here. So on the start, we want to make sure that, actually, let me first, we're going to first assign a variable. And remember, in this, every variable that you're doing in here, except for very, very few ones, all are going to be public. And the reason for that is because this is what's going to be used throughout the state. So if we need to gain access to something else, we're calling back to the robot state controller, or the new robot state controller, and getting what information we need and pulling it back into the state. So the new robot state controller is our hub, if you want to think of it that way. Hub between the states and hub to the rest of the program. And so because we're going to have a robot and we want it to move around, it needs to be a nav mesh agent. So we're going to set up eventually a public nav mesh agent and we're just going to call it the robot like we've done before, because that is what's going to be moving around. And we're just going to kind of fill this in as we go. So what we want to have, what's the most important thing in our start, we want to make sure that robot is going to get the component nav mesh agent from this. So what we want to do, and we'll just take care of this right now, we're kind of going to go in order of it. So we've set up that it needs to be a nav mesh agent, so that means that our robot needs to have nav mesh agent attached to it. So the nav mesh agent itself, when we're the component onto our robot, apparently call it robot 2. We're just going to leave it. Now we're going to, that's fine. We'll leave it robot 2. It doesn't matter. But on here we have what the agent is like. We can create other agents. We're just going to treat it as if it's humanoid. That its base offset is 0.5, which actually we need to raise that guy up just a smidge. And we'll just put him over here for the moment. How its steering is, what speed does it move at, what is its angular speed, acceleration, stopping distance, does it have auto braking? When it comes to obstacle avoidance, walking around these spaces, what is its obstacle avoidance under? The wider the radius, the more space it's going to give when trying to go around those. Height is for going under, right? So if there's a bridge, can it actually go under the bridge? And we have some pathfinding. We don't really want it to go off mesh. We're going to uncheck that one. If it happens to go off mesh, though, we're going to let it auto repath. So that turns that on. All right, now let's go back to our code. And we're going to want, for this guy, we're going to give them 3, or yeah, let's just give it, we'll give it 4 different destinations that it can possibly. No, for this we're just going to give it 2 destinations. We're just going to, it's just going to path between 2 different spots. So let's go ahead and set what those are. We're going to have one of those be, so we can actually move this guy, and move it kind of here in the middle. Yeah, let's move here in the middle. It's fine. Easier to watch. And so what we'll do with this is we're going to create, I'm going to create a new empty game object because I find those just easy for putting these. We're going to put new robot destinations. And then within this, we're going to add 2 create empties, just destination 1, and we'll duplicate it and make it, rename this one dest 2. Let's do destination 1. I'm just going to have them walk over here. And then for destination 2, we're just going to have them walk right over here. So they're just going to path back and forth between these 2. And so what we'll want to do for this is go ahead and we'll bring in those 2 destinations. I was going to think about bringing them in as a list as I've done previously, but I think we're just going to bring in the 2 destinations as that. So we're going to do a public transform because that's what we're going to use to get our destinations. And then we'll call it destination 1 and destination 2. All right, so we'll save this. We're just gonna, like I said, we're gonna build this as we go rather than jumping through. So what we'll do now into our robot 2 is we want to bring in our robot state controller, right? Because that's what's going to be talking to everything. We can minimize the nav mesh agent. We can drag our robot 2 to this, we could have also brought this in through code, but for this one, we're just going to bring it in, drag it in, and then we'll connect destination 1 and destination 2 to their destinations on the code. All right, so let's save that. And we're going to come back to our code. And we're going to then, we need to get a set of variable because we're going to play with the destinations, right? So we want to know public, it's still going to be a transform, but we're going to call this current destination, right? Where is it? Destination. Where is it currently going to? And so what we want to do is we're going to need to set that. But to set it, we're not going to do a random destination, but we are going to still have to do a little bit of code. So what we're going to do is we're going to create a public, and it'll be a transform because we're going to return what the current destination is, or changing. We're going to do transform, we're going to change destination. So if we ever hit one of those destinations, we need to go to it. And so what we're going to do is, actually what we'll do here, first in our start, sorry, getting a little all over the place, we're going to say that our current destination is equal to destination 1. So all we care about is, for this, we're going to start out, destination 1 is always going to start as our current destination. At a certain point, we're going to reach that destination, right? And so what we want to do is then change it. So if current destination equals destination 1, then we're going to change current destination equals destination 2, else, actually we're going to just, we want to return destination 2. So if we're going to, we're going to call this when we need to change the destination. So it's going to be asking, so what the current destination should be. We're going to then change it and say, hey, let's change the destination. If current destination is destination 1, then we're going to return destination 2, else we're going to return destination 1. And this will never happen, but we have to have it in there because we're asking it to return a transform. If neither of those are true, which we've already set that it will be true and it will forever be true, but we have to make sure that it's here. If there's a problem, we're just going to always return destination 1. We're going to say, if there's a problem, return destination 1. No, it doesn't like that. Unreadable cat. Well, then fine. Let's do this. We will instead return. Well, you know, like that. I guess actually we're good with that. It said that was unreachable. Shouldn't, because we have it just be an else. So I think we're okay. If this had been another if else or an else if, then I think that would have been the problem. So it's happy with it. I'm happy with it. We'll go with that. All right. And so then what we need to do is we need to, since we've got its destination, we need to set what state it's going to start in. And we, if you remember from our map, the robot is always going to start in patrol. So we're going to set that part up. And what we want to do with that, because we're going to change states, right? we want to be able to set the states as we need to. So we want to add another function here, but this is just going to be a single run function. We don't need to return anything. So public void, we're going to set the state. And we want to make sure what we're doing is passing in the current state. So we need to have new robot state, and we're going to do NRS. Don't need that one. So what this is going to do is it's going to send in what the current robot state is into this. And the reason that we do that is because we're going to run a few things. Actually, I'm sorry. Let me back up a moment. What we're passing actually in is the new state. We're passing into this. This is going to have, when we go to change the state, it's going to pass in what the new state is. So if we're in patrol and it's been the 10 seconds, we're going to pass into this set state. We're going to call set state, and we're going to pass into it what the new state is, and that's going to go to idle, right? But we still need to run a few things. We need to run the on state exit. And so to do so, we need to come up actually first to our variables, and we need to create another public, and this is going to be of the type new robot state. So it's going to call the new robot states, which goes through all the different parts of the state that it can be. So we're going to be calling to that. We're going to call that our, but we're going to call this current state. Is going to be the name of the variable, because we need to know what that current state is. Because what we're going to do here is we're going to first verify that there is a state. We need to make sure that there is a state. There should always be a state, but just in case, we need to know if it's not. So we're going to see if make sure the current state doesn't equal null. We want to make sure that there is something there for it to do. And so if there is something there, we want to, on the current state, we want to run the on state exit. Right, so if we go back to our robot state, it's going to be pulling from this, and we have on state exit and enter. We're going to add those to our different states in a few moments, but we want to make sure that we run the on state exit first. So if there's anything that needs to finish up in that state, then we can take care of it there. Then we go ahead at that point and say our current state is equal to our new robot state. So the state that got passed in, we're now saying, hey, now this is actually your current state. And the reason we wait here is because we need to finish, because we're using the current state variable to be our reference to what state we're currently in, and we have to do that on state exit first. That needs to run, then we go ahead and switch our state, and then once again, it shouldn't be, but just in case it is, we don't want to run this if current state doesn't equal null. Now we're going to say current state dot on state enter. So whenever we set a new state, whenever it's time to transition from one state to the next state, we're going to run this set state. And set state is always going to run whatever your current state is, its version, whatever the code is on the on state exit. It's then going to switch the state. So now your new current state is equal to the state you're moving into, and then we automatically run the current state on state enter. So if we were in, where did it go? If we were in idle and we transition to patrol, it's going to finish out idle. It's going to move to patrol, and then it's going to start the on state enter and patrol. Always. All right. So with that, we're going to come into our update function. And the update is going to set for the robot what happens every frame, right? So update runs once a frame. And so we're going to, from that, state that every frame we're going to, in the current state, run the dot check transitions function. And then after we check for transitions, if we are still in that state, we're going to run whatever's in the actions. Right? So we have in our transitions is where we hit our on state exit and enters. In our update, we're always checking transitions to see if we switch. If we do switch, then we run those. Right? And then we go to act. Otherwise, if the transitions we don't need a transition, we just run to the action. All right. And then what we're going to do is let me see, where do we need to go from here next? All right, I think where we're going to go to next is our patrolling. Well, actually, yeah, let's set up one last thing. I'm sorry. One last thing in this. We're going to go ahead and add to this, as we've set up in our plan, we need to have a variable for robot energy, right? So what we're going to do is we're going to add that here. It needs to be in public integer robot energy. We're going to set it to 100, right? So, because this is where we're going to deal with that aspect, right? Every frame we're going to be calling, or every second we're going to be calling here. Okay, so we are currently good there. So let's go ahead and go to our patrol state. That's where we're going to be doing a chunk of our pieces. And so now that we have, this is connected to a state, so what we're going to do, we're going to have to use the using Unity engine AI, and it's no longer a mono behavior because it's connecting through to the class. Oops, we still need the colon new robot state. And so we automatically get this red underline because this does not look like this format, right? So what we're going to do, I'm just going to set these up here, and then we're going to be a little lazy, but that's all right. Lazy is good as long as you pay attention to what you're doing. What we need to do is first say public, this is new robot state patrol, which is part of our new robot state controller, new robot state controller, like we've set up constantly, and then it's the base is this. So we're connecting through here, we're adding that part there, and then we're going to do a public override void on state enter. It always adds those. We don't need them. We're going to delete it. so once again, as we've done, here's our on state enter here. The reason we're doing it in a little different order, you could do it this order. The reason for doing it this way is just to make it go through the flow that it's going to go through, right? So the first time we enter the state, we're going to go through the on state enter. Then we're going to repeatedly, as we set up here, public override void check transitions. Right, so that's what we're going to check next. Then we're going to public override void. If we make it through the check transitions, that's where we're going to do our action. That one. And then finally, as we've done previously, when we leave, we have our public override void on state exit. And so the moment we hit that last one is when our red squigglies here went away. And so that makes it the full run through the state, right? On state enter, what happens when we enter this state? How do we transition and make sure that we either do transition or don't transition? If we don't transition, what actions are we going to do? And then when we do transition, what do we have to do when we leave? We can save that. And then what we're just going to do, just to save us a little bit of typing, we're going to go ahead and copy, highlight it all. We're going to copy it. We're going to come over to our recharge. And we're going to paste it in. And then we just need to change this to new robot state recharge. Oh, we need, that's when we need to change this to new robot state. And we just make sure we add the using Unity Engine AI. So that one gets that taken care of quick. We're going to do the same thing for the idle, just to make this go a little faster. Unity Engine AI. We're going to change this to new robot state, which fixes that one. Now we change the idle to idle, which fixes that. And now we have built the basis for those, right? What happens in each one of these states is going to be different. Some will be a little bit more similar, but other ones are just not going to be. And so we've set each one of our states to have the same order of events, right? Every state is going to have potentially have something happen when it first switches. It's going to have a way of checking to see if it needs to switch to a different state. If it doesn't switch, what is it going to do? And then when it does switch, what are the actions that need to be done at the very end? And so with that, that gives us everything we need to basically take, once again, what we've done here and implement it. So we're going to want to go back to patrol. And so on starting patrol, we're going to change the color of the robot to orange. That way we can just track that we actually have made it to that. So we're going to on state enter. We're going to go back to, we're going to call back to the NRSC, the new robot state controller, because that's where we do everything, right? We don't really do anything much here. We do little things here, but anything that we need to get or change, we need to go back to the robot state controller. So we're going to call back to the robot state controller. We're going to get our robot, because that's our game object. And we're going to go ahead and get component. We're going to look for the renderer. And we're going to material set color and color dot, oh, I don't have orange. We are going to, how do we not have an orange? We're going to call it magenta. Why not? Let's go with it. Magenta. All right. It's not set color. Let me hold on. Okay, well, we actually don't want set color. We just want to say color. All right. So what we're going to do on this, and just so that we have it, I'm going to go ahead and change this to, I don't really have a magenta. We're gonna call this magenta. All right. So when we come into the new state of patrol, we are going to change the color of our robot. All right. So that's great. We have two additional transition. We have two transitions, right? We have the robot energy is less than 25 or 10 seconds have passed. So what we want to do actually with this is when we enter the state, we need to set a timer. And so we're going to run the timer on our robot state controller because we're going to use a timer for a lot of things. So let us create here a public float we're going to call it task start time. We don't need to say what it is, but what we're going to do is we're going to create a public void, and we're going to say start the timer. We don't need to pass anything in, so whenever we call start the timer, we're going to set what the task start time is. So task start time equals time dot time. This is going to pass the system time. So we don't need to say what time it is. The system is going to keep track of what time it is. And so that is how we're going to handle that aspect. And so what we're going to do is start the timer. And so on update, let's handle this one additional way, right? Because not everything's going to have a timer. So we're going to do a public bool tracking time, question mark. And currently we are not tracking time. So if we come here, if we start the timer, we are also going to say tracking time equals true. So then what we can do with that is we can add into our update if tracking time, which sets it to the true value. If we wanted it to check on not tracking time, we can just add our exclamation point, right? What we're going to do with that is we're going to, if it's tracking time, then if we're going to have to do one, we're going to set it here for a second and then we'll go back and fix it in a minute. If time.time, which is our current time, minus our task start time is greater than 10, we're just going to leave it that. This will be greater than 10 seconds. We have to have that different because we have an idle being after 5, so that's what we're going to fix in a minute. So then if this is the case, then we're going to end up saying that it's okay to the time is up, which we'll cover that in a minute. All right. So what we need to do with this is we are going to pass an integer. We're going to call it t for time to our start the timer, because what we're going to do is public, since it's so we want it to be a float, sorry. It's not going to be an int because it doesn't like comparing ints to floats. So we'll have a float t, and we're going to then have task time. We're not going to set it, so this is going to pass in how long is the task that we're doing, right? So task time, no, just task time equals t. Helps to spell task correctly. Okay. So when we need to start a timer, we're going to pass all this in. And then we're going to set, if we're tracking the time, we're going to track and see is current time minus our start time greater than our task time. And once that's the case, we're going to update. I think we'll update a variable. We won't be able to send it. And then we'll be calling and checking for that. So let's set the variable here. Public bool task complete, or so we'll call it, and it is not currently complete. We're going to also, just for making sure that everything comes through appropriately and nothing gets messed up, we don't get some false ones, we're going to, whenever we start the task timer, or starting the timer, we're going to say task complete equals false. So that way we can then say here that if that is the case, task complete equals true. So whenever we're starting a new task, we're going to immediately set this to false. So that way it just doesn't run the risk of giving it a false completion. Okay. We've got all that. So let's go back to patrol. And so when we enter this state, we are going to immediately send to the NRSC, the new robot state controller. If I can type, that would be great. And then we're going to send it to start the time. Start the timer. And remember, to do this, we have to pass in the float. We're checking this one to see if it's 10 seconds, right? So we've set that here. Patrol ends after 10 seconds. So we're going to check and see if that's true. The other, so what we'll do, so we've started that on the end, start enter. So now in our override, we're going to first checking time transition. Because we have two transitions, right? And then we're going to write some code, and then we're going to check robot energy transition. Okay, so we're checking the two different ones. So for the time transition, all we're going to be doing is checking if NRSC dot task complete equals true. Oops, it needs to be an if statement. If NRSC dot task complete equals true, we're going to run our transition. And so all we're going to do for that, so if this is true, we're going to say nrsc dot set state, right? So this is how we're setting our new state and running this new set state. And we're going to say it's a new. And what do we do if it's time, right? If it's our 10 seconds, we're going to idle. So we're going to see new, the set state new robot state idle. And we're going to throw that through our NRSC. So if the task complete is true, that's what we're going to do. Otherwise, we're not going to worry about it. But we are also going to check our energy, right? So if nrsc dot energy, robot energy is less than or equal to 25. Let's get that the right way. Then we're going to say nrsc set state new robot recharge. So these are going to be our two transitions. If there's time, if it's more than 10 seconds, we're going there. Otherwise, we're going to check and see how our energy is. All right. So, on the action, we need to so what we're going to do actually in here, because we can get away with it, right? So this is all the code that's going to be running here. But we do have the ability to add some privates in here. And so rather than running it through the new robot state controller, our time tracking to see if another piece of energy, if energy should be decreased, we're going to handle that through the actual states. But what we're going to do, though, is we're going to create a public void losing energy function here on our new robot state controller. So when a second goes by, we're going to remove the energy through here. And so we are going to want to, for here, pass in an integer, and we'll call it energy because we lose different amounts of energy, right? We lose 5 seconds or 5 energy while we're on patrol. We lose 1 energy while we're in idle. So what we're going to do then is we're going to say that robot energy is minus equal E. So whatever current energy is, we're going to subtract E from it, and it'll just go back into there. The other thing that we want to do is, actually we're handling it that way, so we're good. So what we'll do in our patrol state, we're going to add a new private we're going to make this a float. I'm going to call this energy time. Energy time start. I'm going to call it that. And then we're going to, we can just run it right here. It's perfectly fine. Private void energy timer. No, we can't do it here. Okay, so we're going to have to handle this. No matter what, we're going to do this in our... what did I do? Deleted something too much. Oh, I accidentally deleted the end from here. Okay, so we're going to actually have to handle this in our state controller. So what we're going to do is we're going to do another timer that's running, and that works fine. Public void energy timer. Once again, we're going to pass into it a float t so we know how much time are we going to do? Let me think this through. All right, I think what we're going to do here is we're going to, I'm going to leave this blank for now. I think I'm going to put something in there in a minute, but I'm not quite sure what I want to put in there yet. So we're going to say energy timer, and we're going to do a we need to create a couple variables up here. Public float energy start time. Each one of them's a second, so that is perfectly fine. What we'll probably do, actually, we're going to do a string. Actually, we can check current state. Let's see if we can get away with that. And then all of that's fine. So, okay. Let's do one other one. Let's do a public bool tracking energy loss, right? So what we actually want to do, we're only going to be tracking energy loss when it's in our patrol state and our idle state, right? It doesn't make sense to be tracking energy loss when we're recharging, right? That's just a positive. There is no negative on that. So what we're going to do is we're just going to see if we're going to be tracking energy loss. And so we're going to do that through our update. So if tracking energy loss is true, then if time minus energy start time is greater than 1, right? Because this is every second. Then we're going to go into losing energy. Losing energy. I'm just going to put a number here so it doesn't scream at me for a minute. And then what we're going to need to do is we'll take care of it there. Okay, we're just going to say we're losing energy at that point. Okay, so energy timer. We need to say our energy start time is time.time, and tracking energy loss equals true. All right, and so then what we're going to do is we're going to throw into here a temporary variable. If current state equals new robot state patrol, can I get away with that? Okay, we're gonna, since that doesn't want to work nicely, we're just gonna add another variable, public integer energy loss value. So we can just set that. So we're gonna pass in to our energy timer integer, right? Yeah, energy loss value. We can do E again. Energy loss value is equal to E. And so then we're just going to pass, instead of our 4, we're going to pass the energy loss value. So then that's going to pass that down here to E, and then we're losing this. When we lose the energy, though, we have to restart the timer, right? Or otherwise it's just going to all of a sudden, oh, yep, more than one, yep, more than one, yep, more than one. So we need to then also say that the energy start time is time.time. So we restart that second again, it's going to come back through, and there we go. We're going to keep losing our energy that way. And so we're going to call from our energy patrol. We're going to say start the timer. We're going to say start that one. And then the other one we need to do is NRSC energy timer. And we're going to pass in 5. Energy start. Energy timer. Energy timer 5. An integer. Okay, so on the state enter, we're coming through and we are changing the color. We are starting the timer that's going to check and see if it's been 10 seconds. And then we're starting the timer to say, no, are we dropping our energy, right? And then that's going to run all of those parts here on our state controller. Okay. So we've checked our transitions. I'm going to, real quick, here on our on state exit, we want to go in and we want to say that first tracking time is false, right? So when we leave here, because we're not sure where we're going, right? So we're going to say NRSC tracking time is false. And NRSC tracking energy loss is also false. So that when we leave the patrol state, we don't know if we're going from the patrol state, right? Patrol state could go to idle, but patrol state could also go to recharge. And so since we're not sure which one we're going to, it's just going to be easiest for us to go ahead and set both of those to false, right? So that's going to cause these ones to no longer run. We're no longer looking to see if task time is complete, and we're no longer checking our energy loss. All right, so now we have that. We're going to finish off this action because all it's doing is one thing, and that thing is just moving back and forth, right? So we're going to check our distance, which is just using a vector 3, because we're going to check our distance from the robot to its current destination. So vector 3 dot distance new RSC dot transform dot transform dot position, right? Position. Where is the robot currently to the new RSC dot current destination dot position, right? So where are we in relation to that? And we're going to say that if that distance is less than 3 meters, it's a float, so we have to have the F for float, or we don't have to in this, but I always do it for make sure I keep remembering on floats. So we're saying if that distance is less than 3, we are going to set the new robot state controller dot current destination is equal to, and if you remember what we did in a robot state controller on our change destination, we're returning a destination. So all we need to do is run this. Change destination. New robot state controller. New change destination. All right, so that is going to, if we get to that close enough to destination 1, it's going to give us destination 2, and then it's going to switch it because of the code that we're running here on the new robot state controller. All right, and so then all we need to do from here, that's basically just checking to see if we need to switch destinations. Otherwise, all we're doing is new robot state controller dot robot destination, and this is using the destination is using the NavMesh AI. So destination equals new robot state controller dot current destination dot position. So if we are staying here, if we're not transitioning, every update, every frame, we are just going to be moving closer to the next destination, and that's going to be rotating back and forth. Okay, so there we have it, right? So the first time we come into this, we're changing our color to magenta. We're starting the timer to see if we will transition due to time. We are then starting the energy timer, which is then going to see if we get too low of energy. And we check those here in our check destination or check transitions, right? So we're checking to see if we're transitioning due to time, and then if we are transitioning due to time, we're going to go to idle. And if we're transitioning due to energy, we're going to go to recharge. If neither of these are happening, we're going to see if we're close enough to our destination to choose the other one. And if so, do the switch. Otherwise, switched or not switched, we're going to have our destination be the current destination position, which once again calls to the nav mesh and allows us to be going there. And then once again, when we exit, we're going to be setting the track time to false and the tracking energy loss to false because we're not sure what state we're going to. Okay. We are going to, I know this video is running long, but we are getting close. We're going to go ahead and go and do the idle state because the idle state uses a few of these so we can reuse them. So we're going to start actually by copying what's here on our on state enter and add it to the idle on state enter. But remember, idle is only losing 1 energy and transitions after 5 seconds. So the set timer here is 5 and our energy is 1, right? So we're only going to be here for 5 seconds, or we're only going to last for a second or lose 1 energy while we're here. We can also, from patrol, take our on state exit. Right, so once again, we have 2 different ways that we can go from idle. We could go to patrol or we could go to recharge, and we're just not sure which one we're going to. And so we're going to set our tracking time and our energy losses to false. By running these in our enter, that's going to reset everything and turn them back on. So we're perfectly good with that. We don't want magenta. We do want to go blue, right? That is our idle state as we're showing here. So that's good. And then what we're going to do, because it's not doing anything, is for action. So we've got country blue. We're going to do our action next just because this is the only thing it's doing. New robot state controller. We're going to get the component, which is the nav mesh agent, is stopped equals true. Ooh. Which, because of this, right? So in patrol, we can't patrol if we're stopped, right? So what we're going to do with this is we're gonna move this up to the on state enter, and then we're gonna add in our patrol. Since we just don't know, we're going to add the same code and we're going to say false here. So if you're entering patrol and you were stopped, you're no longer stopped. But when we come into idle, we're going to say is stopped as true. And since we're already here, we're going to copy this one more time. And we're going to add this to our on state enter to our recharge. We'll get to Y in a minute. Okay, so actually for this, our action, because we're just being idle, is nothing. There's nothing that we are doing, and that's perfectly okay. We're still saying that since we don't know where we're going, we're turning these off. As we enter, we're changing the color. We're starting the timer, but we're saying it's 5 seconds now. And we're starting the energy timer, 1. Once again, just losing 1 energy and starting that ticking again. And we are now idle. True, we are stopped. Okay, so now what we want to do, I'm going to grab these real quick because once again, they're very similar. So from our patrol state, we're going to grab the check transitions, bring that into idle. So from here, we're checking once again to see if the task is complete. If it is complete, instead of idle now, we're going to switch and say we're going back to patrol. So 5 seconds have passed, and we haven't transitioned because of energy. We're going to go ahead and transition to back to patrol, right? So we're in idle, 5 seconds, back to patrol. And then we have the robot energy once again, less than 25. We're going to go to recharge. So, and that's what we have here. We have the recharge. We'll save that. And once again, we're not doing any actions, right? It's just idle. It's just hanging out. We could have it like spin in a circle if we want. And we're not going to worry about that. We can know that we're in this state by just seeing that we're blue and not moving. Okay, final one. Here we go. We are going to, real quick, before we go anywhere, we are going to state that nrsc dot get component renderer, right? We want to change the color. Material color, and for this one we want color to be, I think this was green if I remember right. Green it is. Okay, it does not equal white, it is dot green. Alright, so when we go to the healing stage, bam, we are going to switch to green. Is stop stays true. All right, and then neither of these states, where was my update? All right, neither tracking time nor tracking energy loss is running, which is great because they would have transitioned out of that everywhere here, right? Patrol and idle, both are setting those to false, which is great. Our only transition here is going to be if NRSC dot robot energy is greater than or equal to 85. And so if that is the case, let's pull up our map again. If recharge, we're going to gain 2 energy every second. We'll get to that in a minute. But we're going to only transition after we are greater than or equal to 85, and we're going to go back to patrol. So what we'll do is we've set that if greater than or equal to 85, NRSC dot set state new robot state patrol, right? So once we hit 85 or more, we're going to go there. We don't need to have any actions here as well. Once again, this could be a spin if we really wanted to. It could put on some cool visual effects of healing something, right? But we don't need to do that. What we're just going to be doing is we're going to add one more thing to our new robot state controller. And we're going to have this be a public void. We're going to recharge timer. Since we know the value of that, we're going to also make one public void gaining energy. That is going to be an int e for energy, which we'll be able to have in a minute. We're going to set it up this. Actually, we don't even need to set it up that way because we will know. And we're going to say energy. Robot energy plus equals 2. And so we're going to add a couple more variables. Once again, we're doing all this here in our state controller. Public pool gain. Did I already set that one? I'm going to, let's just do gain energy. We'll set this up as a false. We already know that, and so we're going to do one more timer, public float recharge timer. Recharge start time, actually. So a float, recharge start time, and a Boolean gain energy. And so we're going to say here in our update, if gain energy is true, if time.time, which we've been doing a while, minus recharge start time is greater than 1, then we're going to run gaining energy. And gaining energy automatically goes there. Like we did before with our losing energy, we need to reset our recharge start time to equal time.time so that every time we gain 2 energy, we restart that and go to a second. And then when our recharge timer is activated, we need to set our recharge start time equals to time.time, and we need to make sure that gain energy is true. So with that, we're gaining energy. It's checking the 1 second. So now we have everything here. We come back to this. And so on start, NRSC. Recharge timer. Right, let's double check that. Recharge timer, yep, that's going to set that. And be running all of this. We're just going to check our transactions. No action is going to happen in this one, but when we leave the state, we are going to say NRSC dot, already forgotten, gain energy is false. All right, that's everything, right? So, okay, let's look at our... We have our robot, which is made up of our state, the robot state, new robot state, and the new robot state machine, where we're tracking our robot energy. We have our 3 states: patrol, idle, recharge. When we're on patrol, we lose 5 energy every second, and then after 10 seconds, we go to idle. We lose less energy on idle, and then after 5 seconds, we go back to patrol. And this continues back and forth until at some point our robot energy is less than or equal to 25. And in that case, we automatically go to recharge, where we do nothing except for gain 2 energy every second until we hit 85 or more. And in that case, we go to patrol. Okay, let us put all this together and see if it works. So we're going to, we've got everything saved, which is great. And so now on our robot 2, we are going to add our robot state controller. Once again, we're going to say our robot is robot. Oops, I already had it here. Ha ha ha. We're going to remove that component. Okay, we have everything here that's got it all there. So we should be able to, I'm going to set this camera about here. I think that goes between everything. And let's see what happens. Let's hit play. And it's not moving. Okay, let's figure out where our issue is. Let me see. Check transitions. Current state, patrol. Alright, let me dig into this. Hold on just a moment. Alright, it's complaining about something here online. Oops. Line 65 is saying that that does not have anything. And so I'm wondering if I'm going to come here, I'm going to grab that. I should have gotten an error if this was the case, but I'm just going to go ahead and copy paste this into all these just in case I made a typo and I didn't even catch it. That is always a chance. Alright, let's see. I've got my robot nav mesh. I've got everything else. Alright, so it's still giving me the same error. Let's, we say that. Alright, hold on. That's what I forgot to do. Okay, we've set that, but I've never set the actual new state. Starting state. So set state, new robot. Since we're starting in patrol, right? And we can get away with just saying this. Okay, I bet you that's going to fix it. So in your new robot state controller, we just needed to have made sure we started the first state. So let's see what that does. Save it again, play it. There we go. We are magenta. We find our destination. We're heading back. We should be getting pretty close to our 10 seconds. There it is, blue. We're going to go back to magenta. We're switching back and forth between those two destinations. We should soon. Now we're recharging. And then at some point we're going to go back to patrol and magenta. We did use a bunch of it, so it should be another second or two, what I would assume. Click here. Yep, 77, 70, 89, 81, 83, 85. We go back. We start losing our energy again. We're resting again. We're losing less energy. We're back. And bam. We once again went under 25. We're going to gain those 2 energy per second. As soon as it gets up to that 85 or more, it's going to transition back to patrolling. Apparently it takes a long time to get that energy back for this robot. We're going to go through one more cycle. And you'll see as soon as it does, this task time is going to change. We're going to hit we're back into our 1, and then we're going to hit energy loss here in a moment. And that's just going to keep going and going. Play with values as you would see fit. Okay, and once again, this all ties back to what we laid out here, right? We have our robot. We're dealing with all of the important parts of the robot, all the different main numerical portions of it, like how everything's working for the robot itself. So this is why we have our robot energy here and all the things that are related to it here. Our states are just telling us what to do here. And that can be checking to see that current energy, the times, where the energy loss is, gaining energy, and then if it, I didn't have it in here, but you could also then be calling to the robot state controller from the state to then check something on the outside, and then get that information back, and then pass that back to the state. And we've got the states of patrolling, which has its on state enter. It checks its transitions. It has its actions if it's not transitioning, and then when it finally transitions, it's got what it's doing on the exit. And we've got the same for idle. Once again, idle doesn't have an action because currently we just have it just stopped. Once again, this could just be a little rotation, a slight back and forth, something like that. And then recharge, same thing, but we're calling a couple different things. And here we're only checking to see if it's greater than the energy, and then back to the action. So for those that have been struggling a little bit with this, I hope that this has been helpful. I apologize for the length of the video, but I really wanted to just kind of dive in and spend some more time showing how it all fits together. So any questions, please let me know. Otherwise, I will see half of you this week and then the other half next week. Talk soon. Bye.